Network Dojo.
mDNS Gateway is a lovely little feature of our controllers that try to take consumer-based technologies and shoehorn them in essentially to our corporate networks. So what is mDNS? So MDM is multicast. So multicast DNS is really what this is short for. Domain name services is a method used to advertise and discover service providers on your network. So a service provider would just be something that has a service to offer. A printer, an Apple TV, number of different devices here. And so the service providers are using mDNS to announce themselves, announce who they are, what it is that they have to offer. So a printer that supported AirPrint services, which is an mDNS service, could basically say, hey, I support AirPrint. Hey, I support AirPrint. And so it tells people what it supports, as well as some information about it, as well as, here's my IP address and who I am and what it is that I offer. And then clients that would want to potentially use these services have the ability to either just passively listen for announcements, or they could actually request to say, hey, does anyone offer a specific service using something called a service query? And to me, it's very much like a client discovering an SSID, right? They could passively listen for beacons, or they could send a probe request and get a probe response. Same deal here, passively listen for the service announcements, or we send a service query that if we don't want to wait for a service announcement. Or maybe there's some devices that don't send service announcements unsolicited. So the service queries come into play there. So when we send these service announcements, either unsolicited or in response to a service query, we send them out as multicast to a special group. On the v4 side, it's 224.0.0.251. On the v6 side, it's FF02::FB. Both of these would be a TTL of 1 on UDP port 5353. So standard DNS is UDP 53. This one's 5353. Which means these announcements cannot be routed. They only live within the VLAN. So the clients and providers for this all to work by default must be on the same VLAN. Otherwise, the clients will never hear the advertisement from the providers and they won't know about them. So this limitation there, that they have to be on the same VLAN, works perfect in a home network, not so great in a corporate environment. That's where mDNS or Bonjour Gateway comes into play. It's designed to overcome this same VLAN limitation. So mDNS Gateway on our controllers. With the mDNS Gateway, the controller becomes essentially a repository for mDNS service providers. So who's out there? What do they have to offer? We're going to build a repository. And this repository is what we can use to advertise out services. So the service provider announcements are not bridged across VLANs. So it doesn't just take, the announcement that a service provider makes and just replicates it out onto every single VLAN. That would be kind of wasteful when you think about, we could have potentially, dozens or hundreds of service providers. We don't want to just spew those out onto our wireless network because this is multicast traffic, right? Multicast traffic always uses legacy data rates. And so that would eat up a lot of our bandwidth if we just did something like that. So it doesn't do that. Rather, what it does is it becomes sort of the central place that advertises things out. So what's going to happen is the controller is going to build this list of repository list of service providers and the services that they offer. And then when someone asks for that service with the service query, if it knows about a provider for that service or multiple providers, it could then respond on behalf of the service provider. So we never send unsolicited advertisements out onto the wireless network once we turn this feature on. We only respond to specific queries, which why if you ever wanted to test this feature out, you can't just use one of those general mDNS browsers that just listen for advertisements, because you'll never see one. You never see unsolicited advertisements on the wireless network. You need a client that can actually request a service, and then you can actually get a response back to that. So in that service announcement, we include the IP address of the service provider. And so when I learn in a service, announcement, hey, when I'm a printer, I advertise, I support AirPrint services. Here's my IP address. And so when someone hears that advertisement and decides, oh, I want to use that printer, they don't talk to that printer via multicast, they talk to it via unicast. So they learned its IP address, they talk to its IP address. From then on, they talk to each other in a unicast fashion. mDNS is only used to advertise services. So if we can get those advertisements onto different VLANs, then the service can be used without anything other special needing to be done, because now we know about the devices. I can talk to any device that I want in a unicast fashion, and then it becomes irrelevant that they're on a different subnet. There's nothing special from there on out. So mDNS Gateway becomes all about what services to learn and who to advertise them to. That's the entirety of the mDNS Gateway process. Which services will the controller learn about? It won't learn about every last possible service from every last possible service provider. It'll learn about a list of specific services, and then it decides which services do I add or do I advertise in response to a query from someone. Not everyone gets to learn about every last thing necessarily. And so the controller has some discernment. When I get a service request for a specific service from a specific client, based off of some configurations, I might not send any information to them, and I might send everything for that service that I know about. Again, it all depends on the configuration. So in order for this to work, we have to turn it on at a global level. It is turned off by default. So if it's not turned on, mDNS actually advertises as normal. And so if we turn on multicast traffic to our wireless clients, multicast mDNS advertisements can actually flow onto our wireless network, and clients on the same VLAN can hear it. But once we turn on mDNS Gateway, that stops. Advertisements don't just flow onto the wireless network anymore. The controller intercepts those advertisements and then starts adding those providers to the master services database. So the master services database controls which services could be advertised to the client based off of certain conditions. And so the master services database is going to have a list of services that it wants to learn. And so we don't learn about every service that could ever possibly be advertised because that list is theoretically infinitely long. There's definitely more common services, but we can create any service that we want technically. So we have a list of services. If we receive a service advertisement for one of those services, we install that service provider into the master services database list. We could then potentially advertise that service provider out to some clients. So what determines whether the clients can learn about a service or not? Well, it always starts that it has to be in the master services database, because we can't advertise something we don't know. But if it's in the master services database, that's where another entity comes into play called the mDNS profiles. So mDNS profiles just have a list of services. A list of services that could be offered, AirPrint, AirPlay, iTunes music sharing, whatever it is. And so it could have one, could have many. Those profiles ultimately get assigned to a client. And so based off of the services in the profile, say I'm the client, and I have a profile assigned to me. This profile says has 3 services on it. I can get a response for any one of those 3 services. But if I ask for something not in the list, I will never get a response for it, even if it's in the master services database. So I can only learn about services that my profile allows me to learn about. And so those are kind of, at the most basic level here, the 2 components. The master services database determines what could be advertised. The mDNS profile, which gets applied to a client session, says which services can that client get a response for, as long as it's in the master services database. All right, so those mDNS profiles become an important part of the configuration. Again, they get assigned to client sessions. Clients can only have one profile assigned to their session at a time. So we can assign that profile in many different ways, though. By default, we use WLAN assignments. So we'll turn on mDNS on the WLAN. We'll assign a default profile, or we'll assign a profile to the WLAN. All clients that connect to that WLAN will get that profile assigned to them by default. We can override that through local policies. Local policies can assign client profile or mDNS profiles as well if I match a local policy. Or we can do a AAA override from a radius server to assign a policy to a particular client using a special Cisco AV pair of bonjour-profile equals profile name. But again, at the end of the day, whichever method is the highest priority, that's the one profile that gets assigned to the client session, and that determines what services that client can potentially discover. So let's take a look at this at a basic level first. So we have mDNS at the general level. We have to turn it on. And then the master services database. These are all of the services that this controller will learn about. So if it receives a mDNS advertisement for any one of these services, we will assign or we will add that service provider to our master services database list. Now, we can add stuff to this. For instance, iTunes music sharing. We can remove stuff from this list, but this is the list. If we receive a service advertisement for something not on the list, we completely ignore it. So I will only be able to learn about devices that offer these services. Okay, that's the start. And how do we learn about it? Well, we just need to receive an mDNS advertisement, either over the wired network or the wireless network. And so if a wireless client sends an mDNS service advertisement, and we have mDNS enabled on the WLAN, we would install that wireless provider in the master services database. If we receive on any of our dynamic interfaces or the management interface an mDNS advertisement, we will add that to our master services database so we can learn it on both the wired and the wireless networks. And when we learn it, it shows up in this domain names list. And so thus far, I've learned about one service provider, and let me see if I can get another one in here just a second. Cat 3. So I have an Apple device. Let me just try balancing the port. Sometimes that forces a fresh advertisement. Make sure it's got port fast. It doesn't have port fast on it. 6. Spanning tree, port fast. Make sure its link immediately moves into a forwarding state here. Okay, so let's see if I've maybe learned about it. There we go. So I've learned about 2 mDNS providers in my network. And in order to be on this list, they have to be advertising a service that's in the master services database. If we're advertising services not in the master services database, we actually see it in this mDNS browser here. So I've received, 1, 2, 3, 4, 5, 6, 7 different advertisements that don't match a service. So the service string maps to a service. That's how you identify a service. It's just none of these services are in the master services database, hence they become ignored. But these 2 have. And so we can see, we see the IP addresses of the device, what VLAN that they were on, the fact that we learned them over the wired network, and the time to live. And so if we don't hear from these guys for a long time, we would eventually purge them out. And if I go over here, they are advertising one of 2 services, AirTunes and AirPlay. So if I go to AirPlay, this is an individual service in the master services database here, we see that I've learned one AirPlay device. It's this MAC address. It's my Apple TV is offering AirPlay service over here. So we've learned one service provider, which easy to count so when it's only one. And this service is actually called out in one mDNS profile. So they're kind of nice little things to know about here. So how many services providers have we learned about, and how many mDNS profiles have this service assigned to it? So if I didn't have any mDNS profiles with this service, even though I've learned something, no one can ask for it because no one's profile includes AirPlay service. So it's kind of important that we have at least one profile that could advertise the service, otherwise we'll never advertise it to anyone. And it happens to be in, right now, the default mDNS profile, which that's the default one. It's pre-configured and it has all the services that are on the master services database to begin with in it to begin with. Okay, so we've learned a service provider here. If I look at the Air Tunes, we'll see both of them are on this list. Hence, we have 2 service providers. This service also happens to be in one profile, which is the default mDNS profile. Okay, now we've learned it. In order to advertise it, that's where the profile comes in. So we always have this default mDNS profile pre-configured. It has every service that was on this list to begin with, but it doesn't mirror it from there on out. So I added iTunes music sharing. Adding it to this doesn't automatically add it to the profile. So they're separately configured here. So in the mDNS profile, we see down below, here are all the services in the mDNS, the default mDNS profile. So if this gets assigned to a client, that client could potentially get responses to any one of these services. But if it asks for something not in the service, like iTunes music sharing, yeah, it might be in the master services database, but my client is not allowed to learn about those services if it has this profile assigned to the client session. Where do we assign the client session, or the profile to the client session? Normally it's through the WLAN. Advanced tab, scroll way down. mDNS is turned on. Here is the profile that we assign to clients by default, but we can override that with AAA overrides or local policies. Okay, hopefully it's maybe starting to make a little bit of sense now. So that was sort of the initial deployment of mDNS. That's kind of what we had, real basic functionality. But then as code levels came up, they came out with some additional enhancements. So in the next wave of enhancements, they added 4 key features. Number 1, origin of service. We can say which mediums, wired or wireless, will we learn service advertisements from. And so we could say, essentially, we could ignore wireless providers and only learn wired AirPlay devices, or only learn wired printers, and ignore wireless, or vice versa. We could only learn wireless service providers and ignore wired service providers on a per service basis. Or we could say all and accept anything regardless of which avenue it came in on. Number 2, mDNS APs. So it allows our APs to listen for service advertisements. So one of the downfalls, if we have a lot of wired service providers in a standard larger corporate network, the VLANs trunked up to this controller where my dynamic interfaces live. My dynamic interfaces may never be on the same VLANs as my client networks. So I might have special wireless networks, and then there's wired networks, and they're completely separate entities. And so if I have a wired device plugged in on VLAN 200, and I don't have an interface on 200, VLAN 200, I'll never receive that mDNS advertisement on my controller, hence I would never learn it. But you know what else is on our access layer switches? APs. And APs can have trunks assigned to them, and so they can snoop in on all the different client VLANs, and if they hear an mDNS advertisement, they can forward that up to the controller, and the controller can learn it through that way. And so on an AP, it's a feature you would have to turn on. You would turn on mDNS snooping, and then you would say, what VLANs are we going to snoop in on? So I could add VLAN 200 to the list. And then I would just need to make sure that I have a trunk configured up to this AP with VLAN 200 allowed on it. And then, yay, I can learn about mDNS service providers on VLAN 200. Forward it up to the controller, and controller can add it to its master services database. So, excellent feature addition there. We have location-specific services which filter out what we advertise based off of location. Here's the way that it's going to work. So let's say that I have, big campus, and there's an area over here where we've got some APs. Now, let's say that my client happens to be connected to this AP right now. And then there's another area of stuff over here. And let's say that I had Apple TV 2 is over here, and Apple TV 1 is over here. So sort of 2 separate areas that are far enough apart that these guys can't hear each other. So if I turn on LSS, or location-specific services, the idea is that when my client asks for a service, let's say it asks for the AirPlay service, if I turn LSS on for that service, for the AirPlay service, when my controller decides, what do I respond with to this request, it'll advertise all wired AirPlay, and then nearby wireless. There isn't two L's in wireless. And so my client, when it asks for the AirPlay service, assuming it's allowed in its mDNS profile, the controller would respond with all wired AirPlay devices, because we don't know where wired devices are. It might be right next to it, it might be 10 miles away. But wireless AirPlay providers would be for any APs for any providers that are either on the same AP as my client or any of its neighbors. And so assuming that these APs can hear each other's neighbor messages, I would learn about AirPlay devices on any one of these APs based off of where my client's currently connected to. But these APs over here, that also happens to have an Apple TV, we don't have neighbor messages heard between the client's AP and Apple TV 2's AP. Hence, my client would not learn about Apple TV 2. So my client will learn about all wired devices and any nearby wireless providers. That's what LSS gives us. So it only filters out further away wireless providers. It'll never filter out responses about wired providers. And then finally, we have priority MAC. We can only learn so many service providers before we run out of space. The idea is that, if we do run out of space, normally the oldest one just gets purged first to make room for a newer one. But maybe there's certain service providers that we never want purged out. We can define those as priority devices, and they never get purged out due to running out of space. So a few different enhancements that go along with this. And then finally, they had one more enhancement, and that would be service policies. And this is a much more intelligent policy engine in terms of what do we advertise out to our clients. So when we turn on policies, it changes the game in terms of the logic of what do I advertise out to my clients. Now, some of the basics are still the same. In order to advertise a service provider, I have to first learn about it. That's always the case. In order to advertise a service provider out to my client, the client's mDNS profile needs to still allow the service. We can't override that. And so we have to have learned it, and the mDNS profile has to allow it. But on top of that, then we have to match a policy that will allow it. And so we have to meet all of those criteria. We've learned about it, the mDNS profile allows for it, and then the client matches a profile that allows its advertisement out to that individual client. And if all of those are met, the client can learn about it. If one of those things are not met, the client cannot learn about it. And so policies just take what we would normally learn and potentially shrink the list down. It can't expand the list, it can only shrink the list. And so rather than read about it, let's take a look at it. So we turn on policies globally. And now once I do that, again, I have to still learn about it. The mDNS profile has to allow it, but then I need to match a policy that allows it. And by default, no policies are matched by any default configured clients. And so the second I turn this on, no one learns anything. And let's take a look at why. When I look at my mDNS policies, there is only one policy there by default. And so everything by default uses the default policy. And in order to match the default policy, I need to match either, I need to have a role assigned to my client session by a AAA server, or I have to connect to the network with a specific username. And by default, I have to match a role named admin, and there's no username matching whatsoever. And unless you just randomly start assigning roles out to your clients, you're not going to match this. And so no one matches the default policy by default. unless they've got extra radius configs going on. Hence, no one learns about anything. We can flip it. We can have everyone learn about everything by default by simply doing something like username any. We only have to match one or the other. So I could have a role of admin and a username of any, and it's irrelevant. I don't have to match both. I only need to match one of them. Once I match one of them, I match the policy, and I can see anything the policy impacts. So to begin with, the default policy impacts everything. And so if I do something like this and hit apply, now it's almost as if policies are turned off at the moment. So far. We'll see how that's going to change. But I am not going to have anything extra filtered out. But now is where we would start configuring individualized policies. So for that, I need a MAC address. So I need to find the MAC address of the device I want to control with a policy. So let's say I want to control this Apple TV. Who can see this Apple TV in any service that it allows? So policies control per device, not per service. They control the device and every service that it could potentially support. So when I create a new service group, I'll call it Apple TV because that's the only thing I'm going to control with it. I can call it the MAC address of the Apple TV. I give it a reference name. This can be anything that you want. It's just a descriptor. And then I have 3 different matching criteria that I can apply to this policy. A location-based matching criteria, a role name, or a username. If I choose location-based matching, I have to match the location in order to match the policy. And then I need to match either a role and or a username. But it's an or between the roles and username. It would be an and between the top and the bottom. I would need to match both the location and either the role or username. So the location filtering is based off of where the requesting client is when they request it. So it's not about where the service provider is per se. It's about where the requesting client is, the person asking for the service. So if I ask for a service that this Apple TV provides, AirPlay, AirTunes, where am I as the client when I ask this? I'll be on some AP. I'm a wireless client. I'm on some AP. Where is that AP? Is that AP in a particular AP group? If so, I would match the location. Is that AP named LAP1? I have to be on LAP1 when I request the service in order to see this Apple TV. Or am I on an AP with a configured location? And this is just a text field on the AP config. So is the AP configured with a specific location where I'm at? And so I can use keywords of any and basically just wildcard this out, and then it doesn't matter where I am. Or I can have specific data in there. With the AP name, there's a special one where I could say same. This is the only time that it matters where the Apple TV is. If I say same, the Apple TV must be wireless and it must be on the same AP as me. But for anything else, it's irrelevant where the Apple TV is. It only matters where I am. But I'll say any. I don't care where I am. We're not going to use location to filter me out. So I can just say add. And then I can add multiple endpoints to this policy, each with their own location matching or lack thereof. And then I could come down here and say, you know what? In order to see this, I have to log in with the username of IceUser1. Or I can do commas to have multiple values. Or I could put roles in here, admin. And again, it's an or between the role and the username. Apply. And so now, in order to meet this policy and discover the Apple TV, I have to either have a role of admin or use a user of IceUser1. If I don't do that, I cannot learn about the Apple TV. And once I start calling out a device in a particular policy, that device is no longer controlled by the default policy. So the only thing the default policy impacts, if I match to the default policy, I can only see things not called out in an explicit policy. Once we call something out in an explicit policy, I have to match the explicit policy in order to see that device, as well as have the profile that allows for it as well, or the policy profile that allows for it as well. You can have the same device in, I think, up to 5 different policies, so it gives you flexibility in terms of different ways to learn about the same device. So you can have different location matching things, you could have different users, different roles, so we can definitely do that, but once we have it in any one specific policy, it's no longer controlled by the default policy. So that would be how policies work. We get fine-grained control over what service providers I'm allowed to learn about. But again, this can only shrink the list. It can never expand the list beyond what we've already looked at in the past. So that would be policies. And I think I've already said pretty much everything I need to say on that one. So that's the idea with mDNS profiles. So I guess understand, details are always a great thing. Protocols, port numbers, those are always excellent things to understand. Understand the interplay of the master services database, the mDNS profiles as a core component of what am I allowed to learn about. How do we advertise or assign those profiles up to a client session, all those different ways that we can do it in the hierarchy of what's preferred over what. And then I guess maybe secondary details of these extra services or extra features and how policies work.